Hello, hello. Welcome to everybody. It is currently the middle of May. I am Whitney Garner. I am located in Durham, North Carolina. As you might be able to see out my window, it's the waning hours of the day, the beginning of the evening here, and I am excited to be hanging out with you. We are going to be doing a part 2 to a lesson that I started last month. We're actually going to be building on this throughout the summer as we prepare for the new GMAT that's coming on board, where we'll have lots more work, it would seem, on data. So what I thought we could do is work on our second part of data and graphs, just because there's so many different types of graphs. We might even actually look at a couple of like really dense graphs from some official practice questions online. But we're going to start again in our YouTube channel. If you're visiting this from the YouTube channel, you can find it in the playlist. For those of you here live, we do have a YouTube playlist where all of our free prep hours live. And I started the first episode of this last month. And so that should be up by now. I think I saw it. So the plan is to talk about graphs in particular and the different types of data that we are going to be expected to know based on our graphs. We will, through the course of the next few of these free prep hours that I teach, we'll be working on things like tables and MSRs, two parts, and also statistics. So making sure that we're really comfortable with all the averages and median, range, standard deviation, that sort of thing, as data becomes a more important part of the GMAT as we move to GMAT focus. So just a friendly reminder that you could certainly have any of a number of fairly standard graphs, bar charts, column charts, scatter plots, line graphs, like intermixed line and scatter graphs floating around. You might even have things like bubble plots. You might have Venn diagrams, pie charts, layered pie charts. And then in the world of graphs, you could have kind of just like anything goes with a picture or a diagram. So we're going to start when we see graphs. Oops, sorry, I didn't mean to pause the recording. Generally speaking, when we have graphs, let me share my screen so that y'all can see them. Yeah. So any of a number of graphs, when we have graphs, what we'll end up with is fill in the blank style questions, right? So we'll have fill in the blank style questions where the fill in, there'll be like a drop down menu. So we working with some drop down menus, and we'll have two blanks in either one or two sentences that'll go with those one or two sentences. And so we're going to try some together. I'm making these a little different because obviously since we're working together, you can't really drop down a menu, right? Like that's kind of not really possible. So we are going to try a practice problem so you can see one. Let's see. All right, I think, here we go. Now it's showing up. Sorry, y'all, I'm having a moment of technical difficulty, but here we go. So you'll get these drop downs, and the way they will work, right? You'll kind of you'll normally click on like a little bit of an arrow and it'll give you a drop down. I've got two examples for you here. I think they're still not quite showing up. Hold on one second. Let's see if I can get this to show up properly. Here we go. All right, and I'm putting the answer choices for these underneath. Here we go. So we're going to start with a bar chart, right? A pretty straightforward standard bar chart. We'll have two questions. So they'll always be two-part when we've got a graph. And you'll have to click on the little like box and there'll be a drop-down menu where there'll be anywhere from 2 to 6 different answer choices. Generally speaking, the goal is to practice eyeballing. So I wanted to give you a chance to just try a question up front. So we'll take about 2 minutes. Generally speaking, for integrated reasoning, we're looking at spending about 2.5, maybe 3 minutes per question. So again, I'll give you about that much time. We'll start with about 2.5, 3 minutes. Send me your message or your answers privately. So I'm going to change it to private. Send me your answers privately when you think you've got them, and then we'll talk about it. All right. So I'm starting to see some answers coming in. Definitely get your answers to me if you have not yet. Okay. All right. So a couple of notes. What we want to start to think about when we're dealing with data, so tables and particularly graphs on the test, right? On the GMAT or the EA, right? Anytime we're dealing with integrated reasoning graphs. The first thing we want to give ourselves a chance to do is to understand what the graph is that we've been given, right? What information. So that includes things like titles, what style of graph is it? Am I familiar with this type of graph? Like a bar chart, many of you are probably pretty familiar with a bar chart, right? But maybe it's a weird looking graph that takes a bit of getting used to. Are there any legends that explain any part of the graph? Is there any accompanying text that goes with the graph? So we know that we're at a produce stand. We're looking at sales by item in April. We're given a bunch of different like fruits and vegetables. We're given some prices. And so this would be sales by item and then the total amount of sales for the month. Generally speaking, when I have a graph, what I'll do is I'll look for a single bar or a single point or a single wedge if it's a pie chart. And I'll say like, all right, what does this mean? How do I interpret this? So what does this bar mean to y'all? So how would I read that piece of information and type it to me privately? Or I guess here we go. I'll set it so you can type it to me publicly if you'd like. How would I interpret that piece of information? Yep. Nice. I've got a couple people typing in. We've got that lettuce would represent just over $400 in total sales. Yeah, exactly. So we can start with either sentence, either drop down. We've got some ratios and then we've got some just like what looks like maybe reading off. So which of these generated the third highest sales in April for produce stand P? Well, I'm going to look for literally just counting them off. This guy looks like he had the highest sales, followed by the second highest sales, followed by the third highest sales. So sometimes one of the answers will be kind of easy. But again, I just wanted us to kind of play with this to start, right? So we've got the ratio of carrot sales to potato sales. Right? So in this month is closest to. So ratio is just a fraction, right? We just need this written as a fraction. And so as we kind of look over this ratio, you'll have a calculator if you come across this in integrated reasoning. So we can always use the calculator, but often we can still eyeball. So carrot sales, as we go look for them, are going to be, well, if this is 200 to 400, this number right here is 300. This looks like it's about halfway between. So I'm going to argue that carrot to potato is about 250 for carrot. And potato, this crazy long one, well, if this is 900, that's pretty close to 1,000. I'm going to call it like 980, 990, somewhere in there. Now, it does really look like a 1 to 4, but just to be on the careful side, I'm going to make sure that 25 divided by, let's call it 98. Yeah, that's a 0.25 or 1/4 or 1 to 4 ratio. And so we'll take 1 to 4, right? So easy enough problem. I didn't want to give y'all a kind of crazy one to start with. But we want to take a moment to make sure that we're reading the table. We're spending some time making sure that we understand the table. Yeah. So just keep that in mind, right? That we're going to do it again. We're going to stick with the world of like bars and columns for right now. So we'll try another problem before we start to move into some, scatter and some weirder looking problems. But one big thing to keep in mind, right? And is this idea of the word approximately, that generally speaking, you're going to want to be eyeballing problems. Even if it doesn't say approximately, you're going to want to be eyeballing the problems and trying to make estimations. So notice if you were off. So I have a few folks that were off on their estimation. I want you to type in the chat window if you got a different ratio. What got you there? So I got a couple people who picked 1 to 5, even a couple of people who picked 2 to 9. What might have gotten you there? Slightly off. Where might your estimate have gone wrong? Okay. Yep. Okay. So I had a few folks mentioning that part of the issue, right? Part of the issue was not taking a moment to really notice where the midpoint line would be. Right? So the line between 800 and 1,000. And so maybe not representing these quite as big as they actually were. I absolutely could have done it. Yeah. Okay. All right, let's try again. We're going to add some new concepts to this, slightly new concepts to this. Once again, give this one a try. Send me your answer privately when you've got it. Okay, I've got one answer. One answer. Okay, so some guesses happening for the second one. Okay, so what was it about this one that was a little trickier? This one was definitely trickier. Was it the chart that was trickier, or was it the question that was trickier here? So chart or the question that got this one a little trickier? Okay, so it's the question. And one of them was a little bit simpler, yeah? Okay, so one of them was a little bit simpler. So here's the other thing to think is that we don't have to start, right? It doesn't matter which one we start with. In this case, maybe the first one was actually a little bit easier to start with, but we don't have to start with the simpler one or with the first one. We could start with whichever one we want. Right, whichever one we want. And we'd be fine. We'd be more than allowed to start with whichever one we want. Okay. But traditionally speaking, I'd say that I mean, I had a lot of messages coming in, more information to process. Oh yeah, after a long day, I get that too. Yeah. So we have a messier graph for sure. This time we have what's called a clustered, right? Like a clustered column, meaning they're next to one another as opposed to maybe stacked on top of one another. So we've got these stacked columns versus a clustered column. The same can all be true for a bar chart. You could have a stacked bar chart where they're like layered on top of one another. You could have clustered bar charts and so on. So we've got a clustered column chart. And so we have a legend tradition, like typically, so it tells us which, color is which. So the lighter gray represents 1950. The darker black is 2000. This is a comparison of the same number of students in 2 different years. So this is how many students got each of a bunch of different grade point averages. And so what I would again say is pick a point or a bar or see if there is a narrative. So I would come in and go, all right, we'll take this thing, this cluster right here. And this cluster tells me what? So I want you to take a moment. What does this cluster tell me? What piece of information do I have here? So I love it. I've got this coming in from a couple of people. We have slightly more students, a slightly higher number and therefore proportion of students received a 3.0 in 2000 than did in 1950. So there were, each one of these lines is 100. So each one of these is 25, 50, 75. So 500 students in 2000 received a 3.0 GPA, whereas only 450 in 1950 did. In fact, it would appear that generally speaking, students in 2000 had much higher GPAs than they did in 1950. Great. So we'll start with the first one. Approximately blank, I'm going to click its percentages. So approximately what percent of the students in 2000 earned at least a 3.0 GPA? So we're going to use this same column, but we're also going to say at least. So that's here, 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 and here. So these are my folks in 2000. I've got 350 plus another 525 plus 625 plus 500. And I want that as a percent. I'm going to divide that by 3,000. Now my percentages are pretty far apart. So I might just do the addition here without even pulling my calculator out. I've got 500, another 1,000. I've got 1,600 with some change, plus another 300 and some. That's almost 2,000. That means, and in fact, it actually is. This is 2,000 about over 3,000, which is 2/3. 2/3 is pretty close to 67%, 66.6666. And so we're going to choose 66.7. Right? So notice that it didn't say higher than a 3.0, it said at least a 3.0. Now, the second one is where things get messier. I need the median grade point average. So I need the median GPA for 3,000 students in 1950. Okay, so 1950. 1950 are my short ones, right? Like, so I'm actually going to kind of highlight these. These are my 1950s. How in the world? Well, let me ask you all this first. What is a median? How do you calculate median at all? How do we calculate the median? What's the formula for median? So median is equal to the middle. Exactly. If I put them in order, it's like the middle number. Or if there's an even number of terms, it's halfway between the two middle ones. So the median is the physical middle of an ordered list. We need to take a second because finding the median from a graph is actually something that often stumps folks. So we're going to take this little, our little question without the graph for a second. And median would be, okay, I put all these people in order. Right, okay. So what am I going to order them by? So I've got 3,000 people. What value are they going to get ordered by? Like how am I going to put them in order? The median of what? Yes, exactly. So the median grade point average, that means I need to order them by GPA. Okay, so I'm going to order by their GPA. So if we were to look at our graph, the lowest GPA is a 0, the highest GPA is a 4.0, and they're in like 0.3. So I would basically say like, okay, I'm going to put all my, however many people have zeros, right? If there were a few people with zeros, and then I would list my 0.3 people, and maybe there's like 4 people with a 0.3, and then 0.7, 0. I would put them in order, right? I would literally put them in order based on their GPA, however many there are. So then once I have all these people in order, how do I find the middle one? Where is that middle person going to be in the count? Where would they be? How would I know how to like find the middle person? Yeah, type it to me if you haven't. I want a couple more guesses to come in. I've only got one guess. How do I find the middle of this list of people? Exactly. Yeah, I could think about canceling values. How many? Like where, how far in am I going to go? How many values are going to be on, how do I know I'm at the middle? Like, yes, I could do it. I could keep going 1, 1, 1, 1, 1, but that's 3,000 people. Which person or which people are going to be right near the middle? It's the moment that I have 1,500 people over here and 1,500 people over here. So I've got to figure out where I'm going to run into 1,500 people. So let's go back to our little chart. I've got 300 4.0s. So I'm going to have, 300 people with a 4.0. Then I'm going to have, 150 people with a 4.0. Sorry, I can do math. So I'm going to have 150 people with a 4.0. And then I'm going to have another, 225 people. So this is the number. This is the GPA. I'm going to have another 225 people that get 3.7s. So I'll have 3.7, 3.7, 3.7, 3.7 listed out 225 times. Then I'll have 300 people with a 3.3. So I'll have 3.3 listed out 300 times. And then I'll have a 3.0 listed out 450 times. And then I'll have a 2.7 listed out 475 times. The question is, have I gotten to my median yet? What do y'all think? This would be my 2.7 GPA. Yeah. So what I'm going to do is I'm going to figure out how many people are in each group. And I'm going to keep lumping groups together until I hit 1,500 people. So I've got, 150 plus 225 plus 300 plus 450. So when I get to this 475, somewhere in this 475 people, somewhere in here is going to be my 1,500 and my 1,501 people. So it means the person who's 1,500th in line and the person who's 1,501st in line both have a 2.7 GPA. That means that my median GPA is 2.7. Okay, so one of the hardest things to come up with is median from a graph. I have seen them ask for median from bar charts, median from pie charts, median from even like stacked or grouped column or bar charts. So just keep in mind that median is not often something that we can read super easily off one of these graphs. We have to be a little bit creative. Okay. So the tip I'm going to give you for median, or what I'd say for median, is notice what they're asking you to find the median of. Okay. So they want the median grade point average. That means you're going to order them by GPA. So you order them by their GPA. That's already there. But then you have to account for how many people there are in each category. So note that the median in this case is not just finding the middle number, 1, 2, 3, 4, 5. What is this? If I came in from either side, 1 from either side, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 13 different GPAs. So it's not going to be 1, 2, 3, 4, 5, 6, 7. It won't be a 2.0. It won't be the physical middle GPA. It'll be, once I've ordered these people by their GPA, it'll be the person that's in the middle. All right, let's look at another kind of like wrinkle of how do I find this weird piece of data from a graph. So here you go. Let's take, again, about 3 minutes. I'll put like 3.5 because these are definitely getting harder. I'm on mute. I got a few answers in this one. So this time we're dealing with like a line graph, right? But it's a stacked line. We got more than one line. We've again got a legend, but no title. And the legend just says that the dark gray with the diamonds, or the black rather with the diamonds, is the average temperature. Whereas the lighter gray with the circles is the electric energy cost in dollars. Okay, so if we pick a point, we're going to do the same thing I do every time. I'm like this guy up here, so I'll pick these two. So these are both August. And this says that in August, the average or the electric energy cost is about 100 and just somewhere between 140 and 150, because 150 would be like halfway between. So I'd say like 145. Excuse me. Whereas the average temperature in whatever this location is just over 80 degrees in Fahrenheit. Okay, so that makes sense. It is definitely hotter in this place in the summer, and energy costs are much higher. And you've got dips in like April and May for energy cost, as well as in November. Seems to be highest in the summer, and it also has kind of a bump in the winter. I guess that makes sense. So the electric energy cost had the greatest month-to-month increase, meaning from one month to the next, between, now don't go looking at every month, look at your answer choices. So from January to February, I want energy cost, that's the circles. From January to February, I didn't have an increase. I had a drop. Ooh, there might be more than one of these that gives me a drop. May to June, okay, that's definitely an increase. June to July, definitely an increase. July to, okay, those are all increases. Okay, so now this question is asking which had the greatest month-to-month increase. Notice that that's just a pure amount. If it had said the greatest percentage increase, we'd have to think a little differently about this. We'd have to look at not just the absolute difference between two, but where we started and then where it ended. But thankfully, this variation of it lets us see that it is the biggest, dollar amount difference is going to be between July and August. Now, I want to know though, in which of these month-to-month changes, so we're going to add on an extra challenge. Which month-to-month had the greatest percent increase in electric energy cost? So let's take a moment and see about figuring that version of the question out. How do I find the greatest percent energy increase? Yep. So in order to figure out the percent, we have to look at what each one is and think percent change. So I've got a number that looks like it's like just shy of 50. So maybe like 45-ish, 48. So we've got one that goes from $48 up to, let's call this estimate, if this is $70, I don't know, let's call this like $73. And then, so that goes from this dot to this dot. The second period would go from 73 up to, I don't know, 103, 104. maybe. And the last period would go from about 103 up to, this looks like it's getting closer to like 148, maybe. It's like a little closer to 150, I don't know, 145, somewhere in there. These are all probably like in the 5 range, right? And so we've got, if we look at what the change is in each of these periods, this change is going to be about 25. This change is about 30. And this change is about 45. So definitely a bigger change in the last one. But compared to where we started, this is change over original. So we want 25 over 48 versus 30 over 73 versus 45 over 103. Notice that in these cases, both 45 over 103 and 30 over 73 are under half. Whereas 25 over 48 is slightly over half. And so this is going to be our largest percent change. If I wanted a largest percent change, it would actually be May to June. Okay, so just make sure that you're paying attention to whether they're asking for an amount or a percent change. For the second question, the average electric energy cost per month. So now we're still same dots. There's no guarantee that we'll use all the, I mean, generally speaking, you will not use all the information given to you on a table or a graph or an MSR. So the average electric energy cost per month for the first half of the year, so let me kind of clear off this. So the average energy cost per month for the first half of the year, so we got dots, so that would be the first 1, 2, 3, 4, 5, 6 months. The average, I could do the calculation, or I could kind of look around at these numbers. Like, is the average going to be 80? No, it was always below that. Is the average going to be 50? Ooh, well, no, 50 is kind of low, right? Like most of the numbers are above 50. So I'm going to guess that it's going to be somewhere between 50 and 80. I would try one more. Let's say if 60 is here, that looks pretty balanced. If 70 is up here, most of it's actually below 70. Most of my temperatures are at or below 70. And so the only thing that would make sense, again, I don't want to have to actually calculate. I want to eyeball. The only average that would make sense here, if we're looking at just this, let me do it a little bit brighter, darker color. If we're looking at just this set of dots, right? Those, technically these 6 dots that align at 60 puts half of them above and half of them below, kind of balancing each other out. And so 60 is our answer. So we're looking for this ability to eyeball. All right, we're going to try one more. And we're going to do kind of a weird graph this time. And we'll do our first, like, how the heck am I supposed to read this thing kind of graph. Yep. Give this one a go. I'll put 4 minutes on the clock, give you a chance to try it out. All right. So which was it on this one? Is it the data that's hard? Is it the questions that's hard? Is it both? What was trickier for this one? So this one may not have looked like an obvious familiar graph at first. We have a scatter plot that's plotting the manufacturing defects as a function of operator experience. Okay, so across the bottom is how experienced our machine operator is. Down the left, on the vertical axis, we have defective parts per 1,000. And then we've got a curve. In this case, the curve is apparently representing average. Okay. So the curve is a trend line. Sometimes we'll see a trend line that shows like correlation or like negative or positive or kind of like scattered, but like they're giving us a trend line, just happens to be a curve in this case. No big deal. So I'm going to pick a point first. I'll pick this guy right here. I don't know what this point means yet. So this point represents a machine operator who had, this is 4, 5, 6, 7, 8. Okay, so this must be divided into 1, 2, 3, 4, 5. So this 4,000 hour spacing is divided into 5 parts, which is kind of annoying. And this is somewhere in between. So I'm going to actually divide them into tens. I'm going to split them in half again. So this 5,000, this is for, if I divide it into tens, each one of these is like 500, right? Like that should sort of get me there. But I can like read it off. So this person would have had somewhere like 34, 33, 34 defective parts per 1,000 is what that would represent. What does the line mean? The line sort of means that this is the basic trend of operator experience with number of defective parts. So when it says on average, that means that I can actually follow the average trend line. So it seems like for both of these, I don't necessarily have to use any of the dots themselves. I can use just the trend line. That's kind of cool. So on average, the machine operators that produce the fewest, so I want the lowest, so that would be these folks down here. But also this is actually even lower. So these folks down here would, on average, produce the fewest defective parts per 1,000, and they're producing just under 25, and they have 16,000. So my answer for the first one is going to be 16,000. For the second one, it says on average, so we'll actually do this in a slightly different color. This time we'll do green. So on average, the machine operators with approximately some number of hours of experience have the same defective part rate as those with 12,000 hours. Okay, so that's going to be these people. So the defective part rate, I'm going to carry this over until I get here. So it's going to be like here. So I'm going to come down. Well, the halfway point would be right here. The halfway between 0 and 4,000 is 2,000. And this is a number that's definitely bigger than 2,000, but smaller than 4,000. And so it's got to be B. So even though the tables or the data that's given might be complicated, we're still often just reading off. We've seen some examples of things like finding the median or finding a percent change where we might be asked to do some more complex operations. But no matter what, we are absolutely working to try and eyeball, to try and estimate, right? And try and get close. And we want to be as effective as possible. If you're at home or on the test center, you can always use either the edge of your whiteboard or the edge of your yellow pad to sort of trace across, edge of your pen or your dry or wet erase or dry erase marker to move across. But you're trying to start to perfect this like eyeballing and estimating to save you time. So what should your next steps be? Well, if you haven't, you definitely want to take a free practice test. We've got free GMAT practice tests on our website. And then come sign up for all of our free study resources. You can try any full live class for free. Session 1 is always for free, so you can always sign up. And you can get those trial classes at the GMAT/classes/free. Once you sign up for a free class, you can also get access to any of our free resources. Another place to do that is to go to our manhattanprep.com/GMAT/resources to get a free trial of our on-demand Interact product. You can try out the free class from there. You can check out all kinds of other recordings, our free Foundations of Math workshops. Several of you attended, and so you're welcome to attend those again. Those are also in the same location. So please come hang out with us, not just on our YouTube channel, but with all of the free stuff that we have to offer. But otherwise, thank you so much for hanging out with me this fair evening. It is lovely to get to spend some time talking data. I'm excited for how this shows up in integrated reasoning, both on the current classic GMAT and as we start to see the new GMAT Focus edition. We'll be excited to see it there too. So if you have any other questions, feel free to stick around. But otherwise, thank you so much. Have a wonderful rest of your night. It has been a pleasure to get to work with you, and hopefully we will see you soon. Take care. Thanks, everybody.